24 people. I don't think I've ever had that many people watch a stream of mine before. Granted, I only do this like once a year for the Game Jam. Okay, let's get started then. What is that? How? Okay. Okay, so, I go by Solus, or Solus. I have a bachelor's degree in game design and development from the Savannah College of Art and Design. And I have been a game designer and gameplay programmer for indie games for about 5 years. Welcome to my intro to game design and development stream. The goal of this stream is to hopefully get you an understanding of how to approach game development with zero prior knowledge or experience. Some of this will be going a bit deeper than what is usually feasible for a 2-week game jam and is kind of more geared towards full development, what you would do out in the field. But I feel it's more important to give the full story here than just what's relevant to a game jam, because then you can keep working on that after the jam ends, or start something new with a longer term goal in mind. It's also kind of slanted towards action games, as that's the stuff I have the most experience working on. This stream is basically breaking down what I do for a living and how I go about making games. So here's the itinerary. First, I'm going to give a brief explanation of what game design actually is, because a lot of stuff online tends to approach this from a strictly academic standpoint that isn't that helpful for actually sitting down and making anything. After that, I'll get into some examples of how it's used, and then I'll go over how the games actually work from a development standpoint, like how they work under the hood, that sort of thing. And after that, I'll go over a technique that I use on how to get started on your own project. This stream is going to be about half for designers and half for programmers, but I won't be covering any specific language or game engine because it won't matter. The approach I'm going to be describing can be used in anything. The big thing that I'm trying to teach here is how to think, which will hopefully make some sense in a little bit. So, also please note the game design is mostly... I've already said that. Is approaching design... The aspect of design that I'm going to be approaching here is mostly a system design standpoint, as in like game mechanics and stuff. There are a lot of different fields for game design, and all of them have slightly different definitions based on where you work and the project you're doing. I'm bringing this up specifically because there's a number of people in the jam making visual novels and working in engines like Twine. That's more or less narrative design and is outside of the scope of this stream, simply because I don't actually know narrative design. It would be if I did. Also want to point out that while the examples I'll be using are for 2D games, anything and everything that I'm talking about will also apply to 3D games. They will be different beasts, but the core concepts are the same. Okay, everybody on board so far? And any questions up front? Okay. And shall begin. Okay, so game design. Before I show you what it is, I'm going to tell you what it's not. Contrary to how it often comes across online, game design is not really a... Oh, okay, cool. Game design is not really a set of static rules that define as if a game is good or bad. It is not a metric for success, and it's not a big one-size-fits-all checklist you want to go through to make sure your game is good. Every game is going to be different. They each have their own design philosophy, some core values that defines what the game is, and they aren't always even compatible with each other to a surprising extent. As an extreme comparison, you will have difficulty, if not absolute. It is basically impossible to take Mega Man's intuitive design and game flow and make that work with Civilization's systemic interface-oriented gameplay. You have to sacrifice the living crap out of one side or the other to make that work at all. To be honest, I would probably try playing that, but it's apples and oranges here. Let's see. It's it's not even that doable inside the same franchise either. A current generation Mario Kart, for example, has level design built around the ability to boost. It's been there for a while, but original Mario Kart didn't have it, and if you put that boost into the original Mario Kart, you'd be crashing into walls constantly, and the game's flow would be completely dead. You'd have to completely redesign every level in the game to make it work. For this reason, critique through comparison of two different games is only useful for forming your own opinions for stuff that you want to make yourself based on what those games have and what they do. Which I guess is I don't want to take pot shots, but it's kind of a long way to describe that Ocarina in Time and Link to the Past, you can't really compare the two without it based on preference. But anyway, just play what you like. It's all good. Okay, so as a result, this is kind of a difficult thing to teach, because I'm not teaching you rules for game design, because they don't exist in the way you'd think. And what works great for one game won't work at all for another. What I am trying to teach you is how to think, how to approach this. I'm going to run through some examples of how and why it's used, and what you can learn from it. And if I can teach anything at all, please focus less on what is good and what is bad in terms of game design, and just focus on what makes the most sense for what you want to make. The only thing that matters is if people have a good time playing your game. If you can do that, you can make fucking anything. And above all else, just please have some fun with the process. So, what is game design? Let me show you. I'll swap to this. And we'll start with this. Welcome to the original Legend of Zelda. So everybody knows the story of this game, how it was inspired by Shigeru Miyamoto exploring... let me do this real quick. How it was inspired by Shigeru Miyamoto exploring caves near his home as a kid, and how he wanted to build a game that would share that experience with others. So, let's get into it. First, so let's talk about this. They wanted the game built around exploration, so let's talk about it. So, first screen of the game. You have absolutely no direction. You don't have a weapon. The game just drops you in. The game tells you nothing. The manual for this game tells you nothing. It covers the plot, the controls, the interface, and just mentions that there's dungeons and treasure. It'll guide you to the first dungeon at the end of the manual, and that's it. It actually shows a map of where the second dungeon is from the starting screen, but it doesn't actually tell you how to get to it. Past that, you're completely on your own. So what do? You wander around a little bit, and you see the cave. That's different, right? So you walk into it, and you discover there's a dude in here, and he's handing out swords. We are under a minute into this game, and the game has already rewarded exploration, the overall idea that this game wanted to present. And we have our first teaching point. Every main element in a game is based around on encouraging and discouraging the player to do something. It's important to consider how any given idea or new mechanic is going to work in regards to your game's idea. You usually want to keep the stuff that reinforces your game's idea and cut the stuff that works against it. And also note that anything that exists in the neutral space between the two extremes is usually fair game. So, let's go back outside and take stock of what we got here and see how Zelda, straight out of the gate, is pushing exploration. We have a manual that informs us, but is directionless. We have a small immediate event that accommodates and rewards us for exploring with arguably the most important item of the game, being the sword that we're going to use more than anything else. If we press start, we see a largely empty interface with a lot of room for things we don't have and don't know anything about. We have a plot. Let's see. Let's scroll down. Yep, we have a plot. Rescue Zelda from Ganon, and we have absolutely no idea how to do that, or even where they are. We know there's a Triforce we need to get. There's a big empty space right in the pause screen for it, and no clue where the pieces are. We have a map in the top left of the screen. Back to this. There we go. The map in the top left of the screen to show us how big the game world is and where we are in relation to it. And we've got the entire overworld to explore however we like. The only option we have from here to explore is to explore. The one lead we had to progression, if we even read the manual, is to find dungeons. And outside of the location, the one the manual shows us where to get to, we have no idea where the rest of them are. So we start wandering around, and the game just unwinds from there. These are all elements coming together to form what we call an end-user experience. Everything about the first 5 minutes of this game pushes you to explore and teases you about the things you can find. This is an ocean of tiny choices that developers made that all contributes towards an idea. That is game design. And that's all game design is. Just having an end-user experience in mind and building a game that supports it in a way that's fun to play. So what we have so far is impressive for something built in the 80s before game design was even a phrase. So it gets better, and we can go deeper. Let's move on to the smaller subsystems, the stuff that doesn't directly push the game's design philosophy of exploration, so much as it simply lives inside of the space created. We're talking about the mechanics that defines the moment-to-moment gameplay. Because on any given screen, there's like even this one where it's just blank and you're just walking around. There's a surprising amount of stuff going on. And there's a lot you can learn from. Okay, first and foremost, if you've played this, you are on a half-tile grid. It's a little hard to see. See it right there? I changed direction. I just pushed right and went down. It's something that you kind of have to feel. It's a little hard to notice unless you're playing it yourself and actively looking for it, but we were actually kind of literally on rails. If we try to subvert it and press a direction different than the game wants you to go, you're kind of funneled onto that tile before you can change direction. And that sounds really weird, right? That's actually a really specific game to build in, or to build in, that really specific thing to build into this game that most people playing this aren't even going to notice. There's a simple explanation for it, but it's an important one. This system exists because it makes two things easier. It makes lining up your attacks with enemies easier, and it makes going into doors easier. Let's scroll down. This isn't something that strictly needs to exist for the game to be playable. It exists to make certain actions done by the game more comfortable. It does stop some weird collisions too. But the primary function, as far as I can tell anyway, is to help get indoors. Because like if we go back down here, like see how it already like pushes it there. If we just vaguely line up into this door, we'll get in it. Because you can't occupy space. I guess like right there, but you can see where the half tile is. Does that make sense? Because it's a lot easier to enter doors this way. Let's see. It makes your attacks easier and okay. But yeah, this exists to make certain actions within the game more comfortable for the player to do. This exists for better game feel. And a good game feel can make or break your game. This is not something you generally have time to worry about for a game jam, but this is extremely useful for full projects. So, with movement covered, let's look at the second most common thing you're going to be doing in this game. Attacking with your sword. Seems basic, right? Push a button, sword pops out. Boop. There's a surprising amount of things happening here, and more importantly, a surprising amount of decisions that were made to get here. First and foremost, the attack happens just about as fast as you can press the button. The physical limitations of your body's ability to press a button with your literal, actual thumb is a consideration for this. And the duration of the animation and attack window is based around it. Hi, Sans. It's a little... As an aside, this is absolutely something taking into account for every fighting game ever. Like the ability for how fast you can press the button and do actual input on a controller. It's a little slower than you can physically do to account for two things, one of which being this was designed for CRT televisions, so there's an input lag, and also so you don't feel obligated to spam the button as fast as you can, as that gets physically uncomfortable. But let's go a step deeper. The attack is near instant, but we can't move when we attack. We have to wait until the animation is completely over. Why is that? What we have here from these incredibly small parts being combined is a system that promotes aggressive play. If we can place our attacks correctly, we're safe. If you hit an enemy, it usually sends it flying away from you, depending on the enemy, and it can't hurt you for a short time. I'll demonstrate right here. Well, I'll try to demonstrate if they'll behave. Oh, no, I kill in one hit so they don't bounce. Well, I tried. Meanwhile, okay, so basically, if we go up to something and attack it and miss, we're rooted on the spot, which can often get us hurt instead of the enemy. Yeah, they're too small. There's an entire risk-reward scenario built into this. This affects the game feel, but in a different way than the grid does. It makes the moment-to-moment combat interesting, because you have to be on top of your game for every attack you make in this game, or it could backfire against you. And the lesson I want to point out here is, as a game developer, you have a lot of things at your disposal to make something interesting. If you ever get stuck and don't know how to make what you're doing fun or interesting, just make a list of everything you've got in front of you and play around with them. See what you can get out of it. There's usually an answer just staring you right in the face. That being said, as an aside, only make a game system as complicated as it needs to be. The fewer moving parts you have, the less of a headache it'll be. Trust me on this, I've made some mistakes. So the third thing I want to point out is the AI, because this is going to be extremely useful for making AI in this jam and in general. Most enemies in this game use a small variation of one or two AI routines. I'll show you. Octoroks, move around on the grid and shoot. Skeletors. No. Same AI routine. Walks around, doesn't shoot. Goya walks around, pauses, shoots. Everything on this screen has the same AI routine. Peahats and bats have their own AI. It's the same AI between them. The difference being you can't physically hit these unless they're stopped. Lionels, as in those big scary things from Breath of the Wild, it used to look like this. Same as Octoroks and everything else. It's all the same AI. And let's see. They're all doing the same exact thing. They're just wandering around to random points on the grid, and then occasionally some of them fire. It's the same basic AI with different coats of paint, and because the movement system is erratic, they all look different, they all feel different, don't they? This exists for a handful of reasons. One, it was the mid-'80s. NES cartridges had a very, very small amount of information you could put on them, and they wanted to get the most bang for their buck. Well, you're in a game jam, so do you. On top of that, with a few exceptions, the enemies had to work with the grid system to make them attacking them comfortable, as we went over. So what they could actually do with the AI was limited to start with. But the lesson here is important. From a development standpoint, you can get a lot of variety of content from just taking an existing thing in your game, copying it, and making the copy work just a little bit different. And perhaps more importantly, how something feels to the player is just about always more important than how it actually is under the hood. So there are a lot of things you can learn from this game. You have a shield to counter the ranged attack advantage enemies have on you, and that's why you have a sword beam too. But it's only usable in one direction at a time. Like I can only block enemy shots if I'm facing the enemy, or facing the projectile more accurately as it's moving towards me. This exists to make the combat more engaging and to negate some advantages they have over you and so on and so forth. But in the interest of time, let's move on to now. For now. Specifically, I'm going to move on to Link to the Past. I'm going to go boom. Okay. So, we're now in Link to the Past. And there's two huge differences from the original that have completely changed the level of the playing field right off the bat. And I'm going to see if y'all can guess what they are. Sword doesn't fly. Yeah, that's one of them. Enemies follow you. No, that's more of a behavioral thing. Okay. The difference in this game is the movement. There we go. Or that's one of them. So, let's go down too far. The grid is gone. Completely. We can now move diagonally. And 2, instead of a thrust, we now have a swing. And the area of attack we're now capable of doing is a bit wider than us. I can now attack things diagonally instead of directly in front. It's still like a little bit more comfortable to do it from the side. You see that? I wasn't even lined up with him and I'm still hitting him. This has completely changed the potential for this game. I mean, there's still a little bit of... speed this up. There's still a little bit of correction. Like, the grid's gone, but if I go... let me get rid of this dude. I shall hit you with my sword, good sir. Okay. So if I get like right here on the corner of this and push up, it's going to move me into place. You see? See how that little right movement there? I mean, that's just more of a comfort thing. But for the most part, the grid is gone. And I'm now able to attack things from multiple languages, multiple directions. And as a result, the AI for this game that is no longer dependent on having a grid to work comfortably for the player is now wide open. The sky is the limit for what is possible. Or I guess the memory limitations and sprite limit, but you know what I mean. Because it was like now they can move diagonally, they can try to reorient themselves in interesting ways. They can do that and ram me into the face because he's an annoying bird. You see what I mean? How much that opens up the AI design. I'm going to leave as a homework exercise for y'all. I just wanted to point out how 2 simple changes can completely change a game. I also want to show that any change, can drastically alter the player space. Whether you're trying to change it initially or not, it's important to be aware of how your game elements interact. Okay. Any questions so far? Wow, I have 44 viewers. I was not expecting that many people. Thank you all for showing up. Okay. Just a little bit more before going on, because I want to make sure everybody's on board so far. Oh, the Dr. W is a Dr. Wily thing, as in Mega Man, which is actually the next game we'll be looking at. Which is going to be interesting because while I have used that icon for forever, I haven't played Mega Man in a while, so don't expect pro level play for what I'm about to do here. I do recommend playing old games as a developer, because like, a lot of the game design stuff that I'm talking about now, there are NES games back in their day, and even if you want to go further than that, like I don't know about Pong, but like Galaga, that sort of thing. All of these games have so few moving parts that they're really easy to analyze and deconstruct, especially as opposed to something like Skyrim, which has a ton of stuff going on at any given moment. So I do recommend playing some of these things if you want to learn from design, especially the famous stuff. Contra, anything Mega Man, anything Zelda. Centipede works, yeah. Like all of that stuff. Just use save states if you have to. Some of them are brutal because they were intended to be siphon money from arcades, because that was how you made a living back then, but you get the idea. Okay, so now that you've seen game design in action, how do you start? Let's say you have some ideas for mechanics or for a story or for some fun things you'd like your players to do. Where do you go from there? To answer your question, we're going to move on to our next topic, space. Specifically, the play space of your game, the environment in which your player does everything. Whatever you're making, if you're not sure where to start by defining the play space. Don't start programming or building it yet, we'll get to that later. But start thinking about how your player interacts with their environment. In an abstract kind of way, or literal, whichever helps. In most single-player games, especially platformers and first or third-person shooters, any given thing your player is doing inside your established game space is usually broken down into one of two things. Player versus environment, or player versus AI. You can build your game exclusively based around either direction if that suits your idea, but in most cases it's going to be a combination of both. As an example, we're going to look at this. Mega Man. Fire and limits. Okay, so this entire franchise is a masterclass on how to use space, but I picked Mega Man 2 in particular because what they're doing here in this level, well, the game in general, but this level as well, is a bit more basic and easier to notice. If you're making an action game, you're probably going to need AI. I could make an entire stream on its own based around how to use AI, but for this I'll try to keep it simple. Your game's AI is an occupant of your game's play space, and how they interact with your player in that space is going to define your game's end-user experience. So let's look at what's going on here. We have three ways we interact with the world. We move left, we move right, we jump, and we shoot. This is before the charge shot and before the slide. That was in Mega Man 4 and Mega Man 3 respectively. So, okay. I am reading from a script. I'm scrolling down from said script. I've spent 2 weeks on this script. Yeah, every AI in this game is based on your ability to do this in some form or whatever. And the AI in this game is actually extremely simple, but they're being utilized by the level design to change how the player is interacting with them. And the level design can be adjusted to make the enemy encounter easier or more difficult, and the Woodsman stage in particular demonstrates this really well. Forewarning, I'm not a level designer. I'm more systems design, as previously discussed, but even I can see this stuff. So we got a little guy up there, right? We're forced to engage it on its own terms. Like, if I were to shoot that, okay, he opened up before I could shoot it. While they're in that ball space, I cannot hurt them. So I have to position myself, I'll get to the rabbit dude in a second, I have to position myself in a way that I can defeat this guy, which is usually either backtracking or tracking or running ahead. See, I can only attack him on his own terms. Let's go to rabbit guy. He just jumps forward, shoots a carrot. I don't know why they shoot out of his chest. That's always been weird to me, but he's exploded, so we're good. Let's move forward a little bit. See, now we're at a slight disadvantage because he's lower than us and we can just have a little bit harder time hitting him. And fast forward, boom, right into rabbit. Okay. So let me skip ahead. See, now we have the enemies we have just been introduced. We're now in a more difficult position because we have to move. Otherwise, they can hit us before we can hit them. Rewind, I'll show you again. The placement of the enemy is right here. So look at it. They're at a down and left of me. I can only shoot at things directly horizontal, and I got hit if I don't move. Well, oh yeah, didn't want to make another animation in regards to the carrot shooting thing, probably. The biggest enemy of game development in all levels, including AAA, is time. So it is entirely possible, even back then, that they would just went, this is good enough, we got more to get done, let's move on. That is entirely possible, and I've lived through it. Okay, so here's a really good, I've forgotten the phrase. I've been doing this for 30 minutes. Okay. Really good example of enemy use with AI is the following screens. We're introduced to this guy right here, and he's not really much of a danger. We can just move out of the way. If we want to hit him, we can just stand right here and just shoot. When those things get close, we shoot, and then he dies. Piece of cake, right? Now we're introduced to a moderate difficulty. To get him this way, we have to kind of like jump forward, otherwise we're going to get hit. This is it, see? This is expecting a bit more of me to beat him. Then we have the third incarnation, which is the hardest of the three. See, I got this tiny little space to work with, and I'm probably about to die. Oh, I got it. Okay. The important thing to notice here is the AI was the exact same for every screen. Oh, that's fine. That's fine. The AI for this was the exact same in every screen. The only distinction is that the level design utilized it in different ways to make it difficult or easier. And that's something that in a jam setting you can do, because like modifying the terrain like this is significantly easier. Oh, gotta do things in threes. Yes, that's a yeah, I follow. Yeah, that's definitely a mantra for Mega Man. And this franchise in general. I think Mega Man 11 mixed that up really, really well. It's a very fun game I recommend. But yeah. So this stage in particular is very organized from that 3-act structure. It has a bunch of different stuff. See, now we're at a disadvantage again because of the way these are placed. But like you get the idea. The rest of this stage is basically doing that again 3 more times. I mean, it mixes it up, like here's a new area, and so on and so forth, but you see what I'm getting at with this. Okay, so long story short, look at your idea, look at how your player is going to interact with it. Really nice of the bats to leave you alone while your health increases, yeah. Look at your idea, look at how your players can interact with it, and build your environment around that interaction. You have a lot of things you can play with to make this work out, but it's important to just recognize how they work. So while we're here, there's a part of Flame Man stage I want to show you because it's subtle, but it's a really good interaction. So this is like early on. So we go through here. See what just happened? I'll do it again. Anyone playing this is going to do exactly what I just did. These guys right here are previously introduced where you can't kill them. They just, your bullets bounce off and they do nothing. So you've got this dude just running, just bolting straight at you that you can't deal with, so what do? You jump. And it puts you on this platform right here, which is where the game wants you to be, because the rest of this level goes here. And it continues up through there and across this lava, which I'm not going to do because this area is kind of annoying to me. But if you've played it, you know why. But yes, that right there, that one little action of using an existing enemy that is previously introduced to enact a player behavior is brilliant. This is a fairly advanced game design thing. Don't worry about this sort of thing if you don't need to. You don't really have to worry about it at all. Just know that it's an option available to you. It's something you can do. You can utilize the enemies to do things in the design space or in the level design to get them to act certain ways. It's just something. It's an option for you. Okay, so I believe that covers the. Okay, so now that you have an understanding of game design, how do you actually start building it? Welcome to basic production. As mentioned previously, this is when we start shifting more towards a programmer's perspective, as they're going to be in charge of actually building your game, but there's still some design material left to do. And if you're the one, anything past this point, if you're the one, if you're managing the project, this is going to be relevant to your skill set, especially like the stuff I'll be getting into later. So, I'm going to start this off by going over what we're actually looking at in this game. What we have here, under the hood, is boxes. Boxes as far as the eye can see, in an ocean of rectangles and squares and the occasional circle. Every asset you're looking at in its game space is a simple shape known as a primitive. And in 2D games, that shape is usually rectangular, both for simplicity and convenience. Mega Man isn't literally an invisible box wearing a sprite. It's a box with a robot painted on it. That box is used to calculate what he's standing on, if he's falling, if he's about to move into a wall, if an enemy is touching him, and so on. We typically call this box a collider because that's what it does. It tells us if it's colliding with anything. And that one simple thing is the backbone for how all games work. Interface-based games like Civilization and some other stuff it's a little bit different, but it can be a little bit different. The way that that's all like interface driven and stuff like that. The way that some of those work is it still has colliders, but only for the buttons that you would click on is the collider. It'll shoot from the mouse cursor down to a raycast down onto it, see if it picks up anything. Don't worry if anything I just said doesn't make sense. If you're a programmer, you don't have to worry about it. But for the just a general idea, it's colliders all the way down. Every player object in every game you've ever played is a collider moving through space. Mega Man has a collider, enemies have a collider. Your shots have a different collider. The ground you work on has a collider, or the ground you walk on has a collider. They're all being monitored and used in different ways, but they're all colliders. Different engines have different ways of going about this. But the principle is the same. From a structural standpoint, you build your game based around how the elements interact with each other, and the most basic and most common form of interaction between two objects is a simple collider overlap. After that, it's just a matter of passing around relevant information of what happens when certain objects touch each other. Brief side note, if you're wanting to do a 3D game, it's a bit different, but the concept's still the same. Just about every first-person shooter and third-person game you've ever played that isn't like skill-based, like CSGO kind of stuff, I'm talking about like Borderlands here, is something called a capsule collider. And it literally looks like a Tylenol standing up on one end. That's what your collider looks like. Okay, so let's get back to this webinar production. Okay, so with the basics covered, let's get into actually making some stuff. So how you start a project is extremely important. The easiest thing to run into when you're just starting out in development, and I have done this myself, is working on things in the wrong order, which can lead to the jam ending without anything to show for it and getting frustrated. You can spend so much time working on things you don't know that you need, and then your project will fall apart. It's an extremely easy trap to fall into. I spent years falling into this trap trying to make stuff on my own before I got a degree, and I'm going to show you how to get around it. If you can do this, you will be able to have something playable by the end of this jam, even if you have to scrap most of your ideas to get it out the door in time. I will tell you up front this process can take some getting used to because it requires that you be absolutely critical and objective about your ideas. Your best, most fun-sounding ideas may simply not work out when implemented. Or they may simply take way too much time to get in the game, and it's important to not get too attached to an idea for that reason. Focus on making the game good and let go of things that don't work. The secret to getting a game up and off the ground is to make sure you build a solid foundation and incrementally add features as you go based on their importance. Not their coolness, or not how interesting they are, specifically their actual importance to having a game. Every idea you have for a game should be organized into 3 separate categories that you will work on one after the other. The core, the content, and the pile. Okay? The core is the foundation of your game, the systems absolutely required to make it a game. The content is where you'll be for most of development, and is where the most relevant aspects of your game are developed. Level design, sound design, art direction, non-core mechanics, all of that goes here. The pile is where the less important mechanics and ideas go. Stuff that isn't necessarily required for your game to be a game, or may not actually fit in within your vision, but it'd be fun to have if you have time. If you're not sure about a mechanic or an idea, it goes in the pile. Everything that can be sacrificed if you don't have the time to work on it goes in the pile. This is also effectively where your ideas for game polish go. The core tends to be straightforward. The content in the pile will be generally somewhat vague because you have to make the judgment call on what goes in what pile, and a lot of that will come down to experience. It's like most things in life, you just got to do it until you get it. But yeah, these three categories are my steps toward making a game. You want your ideas organized and worked on in the correct order, because if you do it this way, at every step of development, you will have something playable. When the jam timer runs out, or you have a friend over that you want to show your progress to, you will have something playable, even if it's not complete. And having something playable is the most important part of development, because spending weeks of your life on something and having nothing to show for it is the absolute number one reason why people burn out and games stop being worked on. And also, it makes you feel like shit. Again, voice of experience. Okay, so, an important side note before we get into it. Outside of game jams in full development, do not start making art assets until you're at the content stage, or at least until your core is stabilized enough that you can start replacing your temporary art assets with real art. Use temporary art assets and random images until you do. The reason for this is because until you get to that point, you may start making assets that you don't know if you can use yet. And as previously mentioned, the idea is to avoid burnout and wasted development. If an idea isn't present and tested, it ain't ready for art yet. There are two exceptions to this rule. One, it is absolutely okay to slap some half-assed art assets together so you can see what they look like in-game and test stuff that way. If you're an artist with a quick turnaround, cool, that's fine, do you. Just don't pour your heart and soul into them. Thumbnails work fine. And two, if you're in a game jam such as this one, you're going to want your artist making stuff straight out of the gate. Do not wait a week and expect them to make full art assets. That is absolutely not enough time and will put a huge amount of stress on them. Okay, so let's move on to the process. Okay, wait, before I do that, any questions before I do? There's such a delay between the recording and the chat that, okay. I always get a little scared that like the chat stopped updating and I missed somebody talking and I'm like, oh no. Okay. So, let's move on to the process then. 1. Find your core. Every game has a core mechanic to it, something so pivotal, so integral to the game that it completely falls apart without it. In some games, it can be a bit difficult to spot, like Europa Universalis comes to mind. It's the interface. Building the interface would be the first step for something like this. But most games tend to be straightforward, once you know what to look for. Every game has a goal, a thing you need to do to complete it, and the absence of that core mechanic makes it completely impossible to complete that goal. This one thing is the foundation that your entire game is built on, and it's going to be the primary thing your player does when they play the game. Generally, for about 95 or 90% of games, your absolute core mechanic is going to be movement. If it's character based and you're moving around, movement is your first step. Your first step is going to be your character controller, the thing that your player moves around. I just said that. Okay. Get player input working. Get collision working. If it's a platformer, get gravity working. Ignore every other aspect of your game and get this up and running first. Don't do art unless in a game jam. Don't do music unless in a game jam. Don't touch writing unless in a game jam. Like I said, if they're in a game jam, they should be doing that right now anyway. Do not touch level design during this step, even in a game jam. I absolutely encourage you to make a little prototype level out of primitives and basic collision to test your character controller, but do not make anything remotely close to an actual asset you plan on using. You just want to test your character controller first. because the character controller is how your player interacts with your entire game. Well, let it feel right first. And also because everything in your game is built around what your character controller does. If you're making a platformer and later change the jump height, you're going to have to reevaluate every level in your game to make sure the new jump height works with it. Because otherwise, it may not work. Maybe if you shorten it, you're going to have to make sure every jump in your game is now doable. If you make it bigger, you may have some uncomfortable jumps. Like maybe, okay, if you're fighting like an AI and you jump too high, there's now a distance you have to wait for you can fall. Maybe that doesn't work well with your combat as you've established it. You see how, like, it can get out of hand, is what I'm saying loosely. Let's see. Yeah. But long story short, the less you have to redo, the faster you're going to get a game out at any level of development. AAA down. So, after you get the character up and going, we now shift to some core functionality. Your characters can interact with other things. How that works depends on the game and the engine you're using, but remember, we're not looking for specifics here, we're just looking for common backbone functionality. If your game is player versus AI, this is where you start with that. Usually based on the code you already got working with your character controller. Most of the AI I've ever written professionally uses physics code previously established by the player controller. 9 times out of 10, player controllers and game AI tends to be the same thing, except with a player input swapped out for an AI routine, followed by some edge cases. You don't have to reinvent the wheel, just have an understanding of how to repurpose your code down the line. If you're not a programmer, don't worry. Or even if you are a programmer, don't worry if nothing I just said makes sense. There's a bunch of programmers in the Discord that will help you with that, myself including. After you got that up, you need to write your interactions. Does your character attack enemies with a gun or a sword? This is the part in which you get that working. Break out the colliders, as we talked about previously, and start building that interaction. A projectile or a sword, in our terms, are literally just boxes that, when active, when they touch an enemy, calls a function on that enemy that reduces the enemy's health a little bit. If it's a sword, the collider is a part of the character controller that just turns on and off when you hit a button. If it's a projectile, the collider is spawned by that character controller when you hit a button and just moves through space until it hits something or goes off screen and is destroyed. To your engine, they're the same thing. One moves with you, the other one moves on its own. And with that, a functioning player object, a little bit of AI, and the ability for your AI and player object to damage each other, your core is now, for the moment, functionally complete. And you have something playable. It's not quite a game yet, but you now have something to show off to others as proof of concept, which is extremely handy if you're trying to make a team. And more importantly, you now have a foundation for everything else in your game to sit on. You will often come back to revise aspects of your core later, and that's fine. You have absolutely no way of knowing up front what all your game is going to need until you find out you need it. So, step 2, test your content. This is where the bulk of development occurs. In full production, this is damn near endless cycle of implementing a feature, testing the feature, and then either scrapping the feature or moving on to the next feature until your game is feature complete. And the word feature has now stopped meaning anything, as I've said it so many times. And this is the step in which you basically start putting in your art and your sound assets. In full production, this step can take months to years depending on the scope of the game. In a game jam setting, this is basically where you bust your ass trying to get the rest of your game together, and you won't have time to test anything. It is what it is. Which is completely fine in the nature of game jams. Time is always at a premium. Everything you arranged for this step, take a look at, break it down into smaller components, organize in order of importance to the core experience, and start building. This step is probably the most vague because what you do in it and what goes in it is completely dependent on what your project is and your own judgment. Okay, so number 3, manage the pile. This step you may find yourself dipping into on occasion as you're doing the content step, and that'll make sense in a moment. This is where everything that doesn't have a direct benefit to your game or is of questionable actual use to your game, but is really cool and sounds like it'd be fun. Any mechanic or idea that can be completely removed from your game or never inserted into your game without the game suffering its absence goes here. Maybe your existing system doesn't support a jetpack boss and would require a hack solution to get it work that you don't have time for, but could be an enjoyable experience to put in the game. This is where that sort of thing goes. As a result, sometimes when you're in the content step, you may find that an idea you put here may fit better than you thought. And so you pull it from here and move it on to the content step and test it out. It can happen a lot, and it probably will happen a lot. Similarly, you may have something that was originally a core feature, and then the game took a turn that made that feature irrelevant, and you need to move it here. Both are completely fine. Game development is fluid. You may find yourself wanting to merge this pile and the content pile, especially, just keep one pile just for simplicity. This is a bad idea, because this pile exists for triage. You need a pile for things that are less important, because eventually you're going to run out of time, either in full production or in a game jam. And if you can keep the content of this pile separate and organized, your game's going to be the best it can be. And that's it. We're done. That's all I got. If you can follow these three steps, you should be able to build anything you need to. Don't be discouraged if it's a little weird. The process does take some getting used to, and some of it just comes down to experience. Like most things in life, the more you do, the better you get at it. Alright, any questions? Hey, no problem. Glad to hear you all enjoyed that. I was kind of nervous setting this up, to be honest. No one says I wasn't there for the whole stream, so maybe you already said it. What's your background in game development? I have a degree in game design and development from the Savannah College of Art and Design, and I've been an indie game developer for about 5 years. Streams archived. This one will be. I will be saving this one. I forgot to hit the record button to record it on my hard drive to put on YouTube, but yeah. So this will be around for apparently 2 weeks on Twitch. If I can find out a way to download it from Twitch, I'll put it on YouTube. Thank you. Okay, so I'm not actually going to be participating in the jam itself. What I will be doing is I will be answering questions to the best of my knowledge throughout all of it. It's literally why I'm in that jam. Because I was born in the 80s, and none of the things... I got a Game Boy when I was 6, like the original Game Boy, and it came with Mario Land, and I was like, this is what I want to do with my life. And then I spent about 15 years of my existence kind of like floundering around trying to figure out how to do this stuff. So yeah, I just really want to help. It's difficult enough starting this stuff on your own, without a direction, so I don't know. I want to help people. Have you given this talk in previous jams, or is it your first time putting a intro together? I did a stream on Unity last year. This is the first one I've done for game design. This stream was really helpful. Now I know that I want to create a Mega Man clone. You'd be surprised. Mega Man is actually like that style of like simple platformers like make really good game jam games, because they have like very few moving parts and have a quick iteration time. So yeah, if you want to make a Mega Man clone, go for it. There is a ton to learn from that franchise. Okay. Any further questions I got are specific to the game I'm making? Visual novel stuff, probably more appropriate for the channels. Yeah, probably so. I unfortunately do not know enough about narrative design to help with visual novels, outside of maybe some programming stuff, but I don't know the language, so I wouldn't know the syntax. Okay, I'm going to end the stream here then. Thanks for coming. I had almost 50 people in here at one point. That was amazing. Let me know if I can help with anything in the chat. And yeah, thanks for coming. Talk to you later.